So my name is Professor Mary Gagen. I'm a member of the Tree Ring Group here at Swansea University, and I'm talking with my dear friend and colleague, Danny McCarroll, who's also a professor in our Tree Ring Group here, about a piece of research that's just been done as part of the UK Oak Project, looking at a new way to date archaeological timbers in buildings. So Danny, I've got in front of me two of the samples from Llwyn Celyn, from this building in North Wales. And I can see that the growth here is what we would call complacent. There's not much variability in the rings. They're quite similar. Why is that a problem for archaeological dating?
Well, this is typical of trees that grow in a moist environment. They've got plenty of water. It's not too cold. So there's just no variability from year to year. And the dating works by pattern matching, like a barcode. Mm-hmm. So it's a bit like a barcode where every bar is the same size. So every tree looks more or less the same. So
there just isn't enough variation from year to year for us to derive a date for each ring?
No, you would need hundreds of rings to get a reasonable match with such a complacent sample.
So as well as the changes in the width of the rings, what you can't see in here is what we do a lot of in this group, that there are differences in the wood chemistry from year to year. There's the hidden signal that does have variability. And that's what you and Neil Loader and colleagues from Oxford University discovered, and that you could apply that technique to dating this wood. Tell us a bit about that.
Yeah, we've been using the chemistry of the wood, actually mainly to look at past climate, because the oxygen that was originally in the water that the trees used is still stored in the cells of the wood, and there are three different types of oxygen in water, and we used the ratio of the lightest one to the heaviest one, and it's not very difficult to measure, and it varies every year depending on the kind of rainfall that we have. So if we have a very dry summer with thunderstorms, we get high values. If we get a miserable summer with lots of fronts, we get low values. And the variability is quite good year to year. And the trees don't care about the water. They use whatever falls out of the sky. And so this variability tends to occur in every tree. And so it doesn't really matter whether the trees are from wet West Wales or from dry East England. You get more or less the same signal.
So what happened when Neil produced these measurements here? So he had a value of the oxygen isotope variability in every ring from year to year in these samples, and he was able to pattern match to derive a date for these samples. What did he find out? Because it turned out that this was actually a very unusual building and quite a special building.
It was. I mean, you're one step ahead there, because before you can date anything, you need to have something to date against. Right. So it took us, I think, about 3 years to build a chronology from 1200 up to 2000, so that we could compare undated samples with that chronology.
So you needed the thing to pattern match against. You had this undated core sample from a building, and you needed to have the reference chronology to compare it with.
And we were lucky. We worked with colleagues in Oxford, particularly Dan Miles, and he works dating old buildings using the conventional method. And he keeps all the samples. So he was able to supply perfectly dated samples for the last 800 years. So when we had the chronology, we were then looking for things that wouldn't date by conventional methods. And this fantastic old house, I think everyone had tried to date it.
Yeah. And
the trees were just growing too happily. And also they used quite short sequences, only less than 50 rings.
I mean, you can see here that these were essentially crop trees, weren't they? That's a pollarding event, presumably. So the rings are very wide, and then they suddenly go very, very narrow as the trees pollarded. And then they would have been pollarding the trees to grow longer stems to use again and again. So these were like production trees, essentially. They were growing happily.
Yeah, we're not talking about the ancient wildwood here. You know, oak has always been an important building timber, and it was very carefully managed, certainly in the medieval. So, and you can see the marks of that management in the ring.
Yeah, absolutely. So I want to ask you a bit about when you and Neil and the other people in the UK project started to think about this, because it was a bit controversial, wasn't it? When you guys reported the first date to some colleagues, they were a bit sceptical. They set you a test, basically, didn't they?
They did, yeah. I think there was some scepticism that it would be possible to date things with so few rings,
Right.
and using this new method. And so we were given a series of samples where Dan, the dating expert, knew the date, but he didn't tell us the date. And so we had to date them blind, with no idea where they came from or what the age was. And there was a set of about 10, I think, and we got everyone right.
You got all 10 samples
all
that
10,
you tested.
yeah, we were
Was
quite
he really
amazed. No, I think he was quite happy, really. But this one was a difficult one, because this is a really important old building. It's one of the oldest standing old
It's a medieval
houses.
hall house that the Landmark Trust own.
Yeah.
What is a medieval hall house? It was, when we read about it, it seems that it's actually a rarity that one of these buildings survived, because it was a phase of great destruction and a lot of the buildings were lost from that time.
Well, actually, this was built slightly after the big destruction. Owen Glendower, the revolt, I think, resulted in enormous destruction of houses across Wales. I'm not sure who did the destroying, both sides, I suspect.
Generally, it's everybody, really, isn't it?
Yeah,
in those
probably.
situations.
But this turned out to be built very shortly after the revolt ended. And it's difficult to think where somebody got the money to build a structure in Wales at that time, when, things would have been pretty chaotic, I think.
Yeah.
So it was expected that the date would come out in the late 1400s, but it actually came out as the last ring we measured was 1420. So the tree was probably felled in the spring of 1421.
So that was the outermost ring immediately under the bark.
The last ring when the tree was cut down.
Right.
So it's remarkably early. And that house was lived in every day from then on, until just a few years ago, when the two gentlemen that lived in it were given a new house to move into, so that the old house could be rescued. It was in a terrible state, and no private individual could have afforded to repair it. But the Landmark Trust, I think with the help of the lottery fund, have taken it on, and it is really beautiful. Fantastic old building.
And it's had people living in it and living out their lives for 600 years.
Yeah. And originally it didn't have a floor with stairs. It was just open to the roof.
Okay.
And they would have had the fire in the middle of the floor. And the head guy, whoever he would certainly have been a guy, sat at the top table. And that...
So in that medieval way of communal living.
Yeah, and the bench he sat on is still there. It's amazing.
Incredible story. What I find really interesting about this is your group and the team took an existing methodology that we do this a lot. We measure isotopes in wood in order to explore the climate signal. And they applied it to a problem in an entirely different field, in archaeology. Generally, when we make advances in science, they're kind of small incremental steps, but sometimes there's a big discovery and someone discovers a way to apply a technique in a novel way, like this, and it's a really big step for dating archaeological timbers, actually, in the UK.
I think it is. I think, to be honest, we came at it because we wanted wood samples in order to reconstruct the climate. And the dating for us was initially a bit of a sideline.
Yeah.
And we thought it might work a bit, but we didn't really expect it to work well. But it works incredibly well. Yeah. So I think it really is a big change in terms of what can be dated. But I think something like 75% of buildings that are assessed for dating are not datable because the timbers don't have enough rings, or it's too disturbed, or the trees have grown too quickly. And this method, using the oxygen, seems to get around those problems really well.
Yeah, it's really, really interesting. A last question I do have to ask you. Our colleague Neil Loader isn't here today to do this, so we're having a bit of a chat about this. And there was a bit of an event that went on in a little group, wasn't there, about what to call this technique. So this is a technique that could be called the application of stable oxygen isotope dendroclimatology to archaeological science. But really, when it comes down to it, it's a technique that uses isotopes to derive a precise date for something.
It is.
So some of our more junior colleagues decided that this technique obviously should be known as precise-isotopes.
If you want to call it precise-isotopes, you need to speak to Neil.